Welcome once again to my channel. In this video, we will study the working of bipolar junction transistor. Now, bipolar junction transistor or BJT works in different modes depending upon the voltage applied between the emitter base junction and collector base junction. Here, I have taken example of PNP BJT. In this case, if I am saying that emitter base junction is forward bias, which means that the emitter has the higher positive potential than the base, and if collector base junction is reverse bias, this means that the collector is at more negative potential than the base. And depending upon the biasings, there are 4 modes of operations. And these are, the first one is cutoff mode, where both the junctions are reverse biased. Then the active, or we can say the forward active mode. Here the emitter base junction is forward biased and collector base is reverse biased. And this mode of operation is very important because in this mode of operation, BJT can amplify any signal. The next one is reverse active mode. So emitter base is reverse biased, collector base is forward biased. And the last one is the saturation, where the both junctions are forward biased. But before studying the working of BJT, you should know a very important concept. And that is, for this we have taken the PN junction diode in reverse bias mode. The first concept is that the depletion region sustains a strong electric field. Now the second one is that what happens when an electron is injected from outside into the right side of the depletion region. This electron will be a minority carrier on the P side. It experiences a strong electric field and swept away into the N side. And this ability of a reverse bias PN junction to efficiently collect externally injected carrier proves essential to the operation of BJT. Now, before studying the working of BJT, here I want to request you that if you have not subscribed my channel, then please subscribe it and press the bell icon to get all the notifications of upcoming videos. And also please watch this video till the end, as I will provide you a Google form link of frequently asked questions on this topic and where you can test yourself in real time. Now we will study the working of BJT in forward active mode. For this, we will follow some steps. The first one is the effect of forward bias emitter base junction, and then the reverse biased collector base junction effect, and the third one is what happens in the base region, and fourth is the current conduction process, and the last one is where we will derive some analytical expressions. Now let's start with the effect of forward biased emitter base junction. Since we have taken example of PNP BJT, so emitter is P type, base is N type, and it is forward bias. Now, what is the effect of forward bias PN junction diode on depletion region? This is the depletion region. So width of depletion region will decrease, and this decrease in the width of depletion region will favors the movement of majority carriers. From emitter, the holes will move towards the base, and from the base, electrons will move towards the emitter. The next one is the reverse biased collector base junction. Once again, here the collector will be P type and base is N type. But in the forward active mode, this collector base junction is reverse biased. So the first point is that this collector base junction is reverse biased, and if this PN junction is reverse bias, then the depletion region width will increase. And on increase of this depletion region, the minority carriers from P side are the electrons, and the minority carriers from the base is the holes, and both minority carriers will cross the junction. So here the minority carrier movement will increase. Now the next is what will happen in the base region. In the forward active mode, we have seen that emitter base junction is forward bias and the collector base junction is reverse bias. So we will study the cumulative effect of both the junctions in the base region. So the first one is the effect of forward bias emitter base junction. Here the first effect is, since it is forward biased, when the majority carriers cross the junction, that is the holes from the emitter side and electrons from the base side will cross the junction, then the recombination of electron hole occurs. This recombination of the majority carriers also contribute in the base current. Now in the second point, since the majority carriers are crossing the junction and recombining, so this electrons which got vanished in the recombination process, or we can say the recombination loss is replenished, is recovered from the external circuit. Now in the third point, we know that the base is the thinnest region of the BJT and emitter is the heavily doped region. Because of this, the more and more holes will cross the junction and there will be a little loss of the holes of emitter, and the rest of the holes will injected to the base and they will become the minority carrier in the base, because base is the N type. So this injected holes will become minority carriers of base. Now let's see the effect of reverse biased collector base junction. Now as we know that in reverse biasing, minority carriers will cross the junction. So once again look into this third point. Here we have seen that holes injected from the emitter have become the minority carriers of base. Therefore, these injected holes are swept away into the collector and get collected into the collector. And in this way, these holes will contribute in the collector current denoted by ICP. Apart from these injected holes, the rest of the minority carriers of collector and base will also cross the junction and form reverse saturation collector current denoted by ICO. Now let's see the current conduction process. To understand the current conduction process in BJT, अभी तक हमने जो 3 steps study किए हैं उनको combine करते हैं. So we have taken example of PNP BJT, and emitter base junction is forward bias, and emitter is P type, which means holes are the majority carriers and base is N type and electrons are the majority carriers. So in the first step, the holes, the majority holes will injected into the base. This will constitute the part of the emitter current, and similarly the majority carriers of the base, that is the electrons, will also injected into the emitter. Combining this, it will form the emitter current. Now what will be the direction of this emitter current? See, the direction of the current will be the direction of holes. So direction of the current will be in this side. Now here you should note a very important point, that since emitter is the heavily doped region, so here the current contribution of holes will be much greater than the electrons. So यहाँ पे emitter current हमारा dominate करता है holes से. Now in the next step, ये इंजेक्टेड होल्स बेस रीजन में, सिंस इट इज एन टाइप, सो यहाँ पर रिकॉम्बिनेशन प्रोसेस होगा. रिकॉम्बिनेशन प्रोसेस में जो इलेक्ट्रॉन्स लॉस्ट हो रहे हैं बेस रीजन में, उनको रिप्लेनिश, उनको रिकवर किया जाएगा एक्सटर्नल सर्किट से. सो द नेक्स्ट पार्ट ऑफ द करंट इज द ड्यू टू द डिफ्यूजिंग होल्स, एंड वी विल से दैट दिस इज द रिकम्बाइंड होल्स. और ये जो पार्ट है करंट का, दिस इज पार्ट ऑफ करंट IB, and we will say it is IB1. This injected electrons also giving the part of the base current, and this direction will be here, and it is IB2. So the total base current is IB1 plus IB2. Now in the next step, the rest of the holes will be collected in the collector region, and this will form the collector current. And due to this reverse bias collector base junction, a very small part of the collector current is due to the minority carrier movement. So some minority holes from base to collector and minority electrons from collector to base. This will constitute ICO, that is the reverse saturation current. But the contribution of this reverse saturation current in total collector current is almost negligible. And in the last step in the working of BJT, let's perform some analysis. Now as we have seen in the current conduction process, the holes holes will move from emitter to base, and let denote this current by IPE. Similarly, electrons will move from base to emitter due to this forward biasing. So the current will be in this direction, and let denote it by INE. So this IPE plus INE will be emitter current. So the emitter current direction will be this. Now holes which arrived in the base region will also get recombined with the electrons of the base region. So here the recombination loss of holes will occur, and the rest of the holes after the recombination loss will reach to the collector, or we can say collected in the collector, and let denote this current by IPC. So this recombination loss and the current due to this is given by IPE minus of IPC. So this INE will be this and this current. And the third part is due to this reverse biasing. If we account the minority carrier movement, then the minority carrier movement will also cause current, a very small current. So first one is IPCO and the second one is INCO, electrons and holes जो minority carrier movement हुई थी. So this will contribute in the reverse saturation current of the collector, and combining this is the collector current, and the direction of this collector current will be this. The direction of the base current will be this, IB. So here you should note a point that in the emitter current, IPE will be the dominating factor, and in the collector current, IPC will be the dominating factor. Since base is very thin and lightly doped region of the BJT, so the base current is overall very small. Now in the next step, let's perform the analysis. So we have seen that emitter current is the sum of the hole emitter current and the electron emitter current. Let it be equation 1. Now we know that the IPE is much greater than INE, and this is our first point. And in the second point, this collector current, the IPC, is lesser than hole current in the emitter region, and the difference is given by IPE minus of IPC. We can say this is the loss of recombination process. And the next point, this loss due to the recombination is replenished from external circuit, and this will constitute the base current. So we have denoted it by IB1. यहाँ पर base current का एक छोटा सा part होता है, that is IB2, उन electrons का जो forward bias movement में emitter की तरफ गए in PNP BJT. Now what will be the total collector current? IC is given by IPC plus ICO. Let it be equation 3. Now there are some alpha and beta factors of the BJT current. So we are going to define the alpha factor first. It is the relation between the collector current due to the holes collected in the collector region with emitter current. So IPC is alpha times of IE, and this is a fourth equation, and the value of this alpha is from 0.9 to 0.995. Now from equation 3 and 4 we can conclude that the collector current is given by alpha IE plus ICO, or we can say that alpha is what? It is IC minus ICO upon IE, where alpha is the current gain in the common base configuration. Common base, common collector and common emitter configuration ये हम next video में study करेंगे. Now here you should note the point that alpha is not a constant. It is not a constant. It varies, or you can say it depends on the emitter current, the VCB potential and the temperature, and also on the type of transistor. And the next one is the beta factor of the BJT current. What is the base current? Base current is basically IPE minus of IPC. Here I am considering only the recombination loss current, not that current which is due to the movement of majority carriers of the base towards the emitter. And we know that IE is approximately equals to IPE and collector current is IPC current. From this, the base current is given by IE minus of IC, or we can say 1 minus alpha upon alpha product IC. So here beta is defined that alpha upon 1 minus alpha, and its value is approximately 100. And from this you can conclude a very important fact that a small change in alpha will leads to large change in beta. Apart from this, from the device physics, the collector current is actually equals to the scale current Is exponential VEB upon VT. And this scale current Is is given by the area of emitter base junction, Q, the diffusion constant, Ni square upon the doping of the base region and the width of the depletion region. So this is all about the working of BJT. And please do not forget to click on the link which have all the important questions of this topic. I hope you like this video. So please subscribe my channel and share it. If you have any queries regarding this topic or any other topic of analog electronic circuits, please write in the section and also give me your feedback. Your feedback is very valuable for me. Thank you so much and have a nice day.